Hey, this is Donald Heslop, dual CCIE and owner and principal of Padlock Technologies, here with another blackboard or whiteboard video. I did the series on Cisco Secure Access, and now the next one we're going to do here is Cisco Secure Firewall. Now, I've implemented a lot of these things in a lot of different environments and a lot of different architectural designs. So, I can talk about it a lot, talk about it in nauseum, but we're going to start from like beginner concepts, what it is, what's the whole purpose of it, the history of it, and then we'll get into some advanced examples and advanced designs during the series. So the first thing I'm going to do here is what we're going to talk about is Cisco Secure Firewall, FTDs for short. So Firepower Threat Defense Devices. So if you are someone like me back in the day, I'm really dating myself with this one. There used to be this thing called a PIX firewall. This was the first firewall. And then it went from PIX to ASA. And then went from ASA to ASA plus SF module. This is called the source fire module. If anyone implemented that, you already know what a pain that was. And then it finally has gone to the FTD, or Firewall Threat Defense Software. That was the evolution of how we got here. Now, what is the difference between an ASA with an SF module in it and an FTD? So, and I'll get to the ASA as well, but I just want to focus on the last two. So, back in the day when we were implementing these things, the ASA didn't have any layer 4 to 7 functionality. That was the whole purpose of the acquisition of SourceFire. So what they did was they kind of made two. It was a module. So let's say we have an ASA here, and I think it was like the 55 something, and then they would have this SF module that would sit up in there, right? So now, what you would unfortunately have to do is manage. You have to manage them independently of each other. So you'd have one side to manage the ASA, the other side to manage the SF console. Now, this would give it that layer 4 through 7 functionality, but it was kind of, let's just be honest here, it wasn't the best integration, right? So to get stuff to go to the SFR module, you would have to do some sort of policy or service policy. You'd have to use what they call MQC, which is a modular queuing command, and then the thing called MQF, which is the modular queuing framework. Basically, what you had to do is you had to create a class map that matched all traffic, all traffic, and then you would have to do a policy map that sends all traffic to the SFR, or SFR technically, that's what it was called. You would send it to the module to get it inspected, and then it would go through the inspection module, come back out. So it was a clear, like, two separate things. Pain in the butt to implement. I mean, it worked for what it was used for, but then Cisco got smart and actually created the FTD software, which combined these two elements. So it combined the ASA side, which they call the Lena, and the source fire side, which is technically the SF engine or the inspection engine, into one platform. So now you don't have to manage two different management consoles. You just manage one. Now, over the years, the original, when the FTD first came out, I think it was like 6X, which was the dark ages. 6X, what they would do is, from an FTD standpoint, the one thing that was missing was like feature parity to the ASA. So a lot of things that you could do in the ASA, you couldn't do in the FTD when in the 6 dot ages. Right now, it's, feature parity is coming out. I mean, to me, the FTD is pretty excellent when it comes to other platforms, right? And those other platforms that the FTD kind of fights against are in the market with let's just be honest here. It's Palo, and there's Fortinet, and then there's Checkpoint, are the big players. All great firewalls, doesn't really matter. Where the FTD kind of beats the other three major competitors is integration with Cisco security platform, platform. So what is this? This is something like Identity Service Engine. If you have that, you're better off going with an FTD because you can hook the FMC into the FTD, and I'm gonna get to that on the next whiteboard. You can hook into that and do something called, SGTs, or security group tags. So now you decouple the subnet from the actual user, so to speak. So it doesn't really matter. Once they get authorized, they get this security group tag, and then you can create your rules based on the security group tag. That way, that person or that traffic cannot escape by going to a different subnet. Because some people can, if you think about attackers, they move laterally to a different subnet. If you have subnet to subnet rules, well, if I go on a different subnet, I'm going to negate whatever rule is stopping the traffic from the subnet I came from because I'm no longer on that subnet. But if you get SGTs involved, you can never escape the SGT, right? And that's a certain design as well. So we got ICE that you can integrate with. If you are using Cisco Umbrella, you can form tunnels to Umbrella and then offload the SSL decryption function and all that good stuff in the Umbrella. Umbrella is kind of old in the tooth now, or long in the tooth. So if you got the new version, which I call Umbrella 2.0, is secure access. You can hook it into secure access, right? You can hook it there. Do the same functionality even more with secure access that you can do in Umbrella. If you are an Umbrella customer, I would probably move to secure access because you're going to get all the functionality in Umbrella and more. And if you don't know what that is, you can look at my other series about secure access and the whole framework of that. So what is the difference from an ASA and the FTD? Now, I have seen some people buy FTD hardware and put the ASA on top of it. Don't know why you would do that because you're kind of missing the layer 4 through 7 inspection stuff, but some people do it for reasons. So we look at the comparison here, and when I say reasons, I don't know what the reasons are, but they just, for some reason, people buy that and do that to it. So we got the ASA, we got the FTD. So as I said before, without the SF module, layer 1 to 3 only. FTDs, layer 1 through 7, right? And obviously you got to have some licenses in order to do that, right? FTD, management, and data plane on box. Meaning you can have 10 ASAs, all ASAs, all of them are different because you have to configure them on box, everything. FTDs have the same, you can do, I'll say management and data plane on box, which I would not recommend using FDM if you don't want to buy the FMC license. But then you can decouple, I'll just do that, management from the data plane via Secure Management Console. Now, this used to be called the FMC, but they call it Secure Management Console now. So what this means is you could get the FMC or the FCM. It's just a management function. You control everything from there. Policies, configurations, all of that will get set on the FMC. Then that will get pushed to the FTDs for just data plane, right? Data plane will work regardless if the management goes down. Let's say they lose connection to the FMC, management will still work, but your configurations are now local to another box and not on box. So if that box ever blew up, well, you got the configurations on the FMC, you just get a different box, same model, just get the same model of box, a replacement, and then you just dump all the configuration back into the new box. There's no need to try to recreate it from scratch. So the management headache is pretty much gone, or the configuration headache is pretty much gone because everything is on the FMC. Now, the FMC can also do HA. So the beauty of that is if you lose one FMC connection, it blows up on you. Well, you have the backup, and everybody has that backup connection to the secondary FMC, and then you can still manage. All right. The only thing about the FMC is if you lose connection or if that goes down, you lose administration capabilities. You can't make any changes, right? Because that's where the change come from. Without the SFR module, ASAs, no inspection of traffic. And like I always say, you can't protect what you can't. You can't fight against something you can't see. So you can't see it, can't expect it, you can't protect yourself from it, right? With the FTD, has all the layer 4 through 7 inspection capabilities. All right, so you can do, URL filtering, malware, IPS. Now, IPS, you got to tune it a little bit to make sure it fits your organization. But if you tune it correctly, IPS will work perfectly fine. You can do, it's a whole bunch of rules that you can put on there. And I'll get into that to the next slide. But there's a lot more comparison, but now I'm going to jump off the ASA because they're still in the wild, but they're slowly but surely getting deprecated. And then we're going to talk about certain functions. Now, one of the things I'm going to talk about is the FTD access control policy. Now, if you look at my secure access series, you'll notice that the access control policy, it's going to be a phrase that I'm going to use a lot because everything's getting put into that category now of when it comes to rules, how to make rules. It's basically an access control policy. So with that access control policy, that is the main policy. This is where all your firewall rules are going to go. So it's going to be, source, destination, port, application, and then an action. Now, there's a whole bunch of stuff other than that, but that's just general what's going to be in your, and these are called ACEs. So your ACP hold ACEs, or access control entries, right? Think of the ACP as a container that houses ACEs. Now, there's a whole bunch of stuff from the FTD that you can add on to this. So we have, if you want to do it on box, SSL decryption policy. SSL decryption, decrypt. And this is going to be inbound and outbound. And I'll get into that in another series. Then you have pre-filter policies. Now, these pre-filter policies allow you to basically bypass the ACP for certain amount of traffic, for certain kind of traffic. Now, I'll use an old school the dark age 6X days. In the past, FTP used to break. So what you would have to do is create a pre-filter policy that would say any or whatever it's coming from. I'm just going to use any for now. That was port, FTP, which is a combination of 20 and 21. Just bypass the ACP. Because when it was going through the ACP, even if you had a rule that says, okay, allow it, it would sometimes break it. But that was in the old 6X days. So now you can do that. Now you have an identity policy. ID policy. Now, I like to use the phrase identity is the new perimeter. You'll probably hear that all over the place. But what that means is your policy is no longer based on subnets. It's based on identity. So these are like AD groups. So certain AD groups, right, are Entra ID groups. Because in 7.6, which is what I'm testing now, you can do, I think it's in 7.2 or 7.4 now, you can do Entra ID with a connector, and then you can grab those attributes from Entra and say, okay, I'm going to make my policies based on that. This is a better control of than source and destination, right? Because with the old school layer 3 source and destination, if, like I said before, if you pivot to a subnet that this rule doesn't block, then I negate this whole policy to begin with. But if I do ID or identity policy, hey, if you're in this AD group, unless you got into my Active Directory and changed your group membership, you pretty much can't escape this. On top of this, the one thing that you can put in here, and I forgot to put in the ACE entry, is if you integrate it with ICE, and I talked about integration on the other whiteboard, which is SGTs. So would it look like it would say source SGT, SSGT to DSGT, so source and destination SGT, and you can create a rule based on that. Then on top of this, you have your security intelligence policy, Intel, aka DNS policy. Now the good thing about this, in the new versions, you can actually do a local DNS policy, right? And you can configure it there, or you can tie this in the Umbrella if you're using Umbrella. And then you can take your Umbrella DNS policy and say, okay, the first thing it's going to hit is the local DNS policy. And then if it passes the local DNS policy, I'm going to use the Umbrella policy second, just as a second check. But if it blocks it here, then I'm going to block it based on the Umbrella policy. Then you have QoS policies that you can put in there. Now the QoS for this is policing only. There is no shaping, right? So no shape, meaning that's a hard drop. So I would be careful using QoS policies. There's all this stuff ties into the ACP policy. I forgot, don't want to do this. This is one of the big ones. Malware IPS policies. Now this is going to be on a per ACE basis. So there's no global one that you just attach to the ACP. You would actually attach it to the ACE entry per entry to decide, hey, whether I want to go through malware or IPS. So I think I'm going to stop here, give you a basic overview. Actually, no. Let's go with some design concepts here. So there's a couple ways you can do this. So FTD, I was going to stop, but I think this is important, so I don't want to stop here. Design. All right, there's a couple of things you can do. So you have your total package, which is FTD on box management. Now this is going to be FDM. These are for people who do not want to buy the FMC, don't want to go through the hassle. Now I will tell you, FMC managed FTDs and FDM managed FMCs are totally different. They do not look the same. They think of FDM as the FTD version of ASDM when you used to have the ASA world, right? But it's a learning curve because it looks totally different. So if you go from FMC managed FTDs to FDM managed FMCs, you will see the difference in it. So you just got to be careful. Then you have the other design, which is the FMC or CSM. I'll do CSM, Secure Management Console, which now controls multiple FTDs. All right, I'll just use two. I'll put that link in there and say we'll just say these are HA. All right, so in this case, all management function, bidirectional communication, this is all management, right? FMC controls, policy and configuration. And then FTDs control data plane, right? So this is the forwarding of traffic, right? So when people go and want to configure ACP, they will configure it in the FMC, and then they will deploy it to the FTDs, and then the FTDs carry out the data plane, which is the just forwarding of packets. Now this tunnel here is called an SF tunnel on port TCP 8305. So if you have an inline firewall somewhere and you're blocking this port, you're effectively losing management to the FTD. Now there is a third way to do this, and I think it's and this has come with the 7 version. The new way is CDO, Cisco Defense Orchestrator. They call it something now. I think it's Cisco Security Control now, but we're just going to call it by its old name, Cisco Defense Orchestrator. This is a SCM in the cloud, right? Now, there is a difference between Cisco Defense Orchestrator, or what they call CDFMC, CDS FMC, SMC. There we go, FMC, SMC. So basically, in the newer versions, one of the things that was a problem is in the past, you'd have a separate management interface on each of these boxes, right? Which was technically in its own VRF, so it couldn't see the routing table. You cannot take a data plane interface and make it a management interface. This was a problem when you had FMC in, data center that was controlling FTDs outside the data center. This management port would technically need to be exposed to the outside world, or you would do a loop back, which this was definitely a problem. You would basically put this IP address or this management interface to a core address and then loop it through itself so that you can basically come back to the FMC to get managed. Complete was crazy to do that, but you had to do that in the past. And the problem is, if this box had an issue for some reason, you lost management and data plane. Now, in the newer version, these outside interfaces could be management interfaces. They allowed you to do that capability now. And with CDO or CDFMC, you can now onboard devices directly into the cloud and then management from anywhere in the world. The biggest problem with this version, and I've done this conversion a bunch of times, and I do it now. If you're somebody that wants to do this, again, I'll have a description and a link that goes to a discovery call. We can talk about doing this whole design for you. In the past, you would have to, if I was a network admin over here, NA, in order to manage these FMCs, I would have to RA VPN into my network, into the FTD, to get to the FMC to manage the FTD, right? With the CDO, I could just log into CDO, manage my FMCs via this data plane management and data plane link. Let's see, I'll use red. Manage it this way. Get the same functionality, but I don't have to go in the RA VPN to get that. Now you can also, if you want to, if you paid for the FCM and you don't want to get rid of it because you pay for it, you can actually hook CDO or CDFMC. You can hook it into your on-prem FCM. Right now, this completely eliminates having the RA VPN in it, but you can go to CDO, which goes to your local FMC through a API. You're going to have this API integration here. Back to that keyword integration. You can't really do this with the other solutions. You integrate it with an API, and what that would do is allow you to open up your local FCM from anywhere. Now, you do have to, in order to do this, you do have to give it an external IP address, and then, because it's going to say what's the FQDN externally to get there. So you're still going to have to go through your FTDs to get to FMC, your local FCM, and then get to the FTD. That's why this whole cloud FMC or CDM is probably the better solution, because there's no point in having to jump from the cloud to local to FM that goes through the FTDs to get to the FMC to manage the FTDs. You might as well just manage it all in one box. So that's, from a design standpoint, that's the management design. There's plenty of ways to do that. Now, let's talk about, last topic would be, overall design. What would you do, right? In terms of building one of these. So overall, so let's say FTD hardware design, because that was the management design, right? That I just went over. So hardware design. So you got a couple ways you can do this. Again, single box, one box, FTD. I don't like this because one is too close to none. All right, one box, too close to none. This box ever disappears, you're down. So then you have two different type of HA. So you have FTD1, FTD2. HA, but this is active standby. All right, I see people use that the most. You do HA for like VPN concentrators, or if you don't really care about having a box completely just on standby mode, not being used, then you just do active standby. Something happens, automated failover should happen from primary to secondary. You shouldn't really notice anything from a data plane standpoint downstream. So you'd have like a switch here, and then all traffic would go through primary out to the internet. And then if that actually goes down, then it goes to secondary out to the internet. So that's what you use most of the time. I've seen this hardware design pretty much, I would say 90% of the time. Last but not least is 1, 2, 3, 4. Now you can go up to 8, but I'm just going to use 4 for right now. You have clustering. So what clustering is, and let's put the switch. What clustering does, just router here. So what that does is it makes, you can go up to 8, and it'll make 8 boxes look like one big firewall. And you would do this method, you would usually do this at the INET edge or the internet edge. If this was an internet only firewall, you're not doing REVPN or anything on this. So if you would break this out, what this would technically look like downstream, which would be your core switch. And this would be your REVPN. The active standby would be your REVPN edge or your WAN edge or whatever you want to call it. And then the clustering would be your internet edge. All right. Quad zeros will be coming here. And then your more specific routes or your RFC 1918s or whatever you want to call it will be coming from this side. All right. Now you would do this clustering to maximize the throughput of all the devices. What this looks like is traffic can go to any one of these. Right? Any one of these, they go out to the internet and come back. Now, I'll get into this concept in a couple other videos, but these are the hardware designs you can get. Now, I think that's what I'm going to leave it at for now, because I can talk about FTDs and design and little intricacies about the FTD platform and integrations. This video will be, 24 hours long, and you scratch the surface on some of the things. So what I'll say is, if you are thinking about getting an FTD, if you're talking to your Cisco rep or you're talking internally and trying to migrate from an ASA to an FTD platform, there's a description below. Let's talk at padlocktech.com. This is a discovery call. It is not a sales call because I don't even know what you're doing yet. And we need to actually see where you are before we can tell you where you're going. Click that link below. Schedule a discovery call with me. We can talk about exactly what model you need, because there are different models here. And for your situation, you don't want to buy an overpowered firewall that you don't really need. So you need a certain version of firewall. Then we could talk about design, where it fits at in your network, and then some of the integrations and next generation solutions that this platform has that you can actually take advantage of. Once again, this is Donald from Padlock Technologies, dual CCIE. I hope this video was informative, and thank you and have a nice day.